Now we're going to solve linear inequalities. I know you've done this in the past, but maybe not in this way that I'm going to show. Learning this process will help us later when we do quadratic inequalities and polynomial inequalities, which is later on in the semester. So let's get started with this one. Solving linear inequalities. Linear inequalities are solved in a similar way to how linear equations are solved. But there are actual sections on the number line that will quote-unquote work, which means it'll make the inequality statement true. So first step, change the inequality symbol to an equal sign and solve the resulting equation. So we've done step 1 before in our past. Step 2, we're going to graph the solutions that we come up with on a number line. We're going to use solid dots on the solutions to represent less than or equal to or greater than or equal to, or open dots on the solutions to represent less than or greater than. Now once we've done that, step 3, we've got to check each region by taking a test value out of that region and putting it back into the original inequality. We're going to shade sections that make true statements, but we're not going to shade sections that give false statements. So we've got some problems that we're going to practice on. So we're going to solve the following linear inequalities by using this process. So let me make sure I can see step 1. So first, look for your inequality. Here it is. I'm going to change that to an equal sign. And move this down. Okay. So we change it to an equal sign. So when we have this, first thing we do is we distribute the negative 4. So I'm going to have 8 minus 8 plus 4x equals negative 2x. Combine like terms. That will give us 4x equals negative 2x. Get my x's to one side. I'm going to add 2x. So I should have 6x equals 0. And then divide by 6. So x equals 0. So that's my solution. So I need to put it on the number line. And because it's a less than or equal to, I'm going to use a solid dot. So let me get my dot down here and put it on 0. There. Okay. Now, if you'll notice, if I could cut this number line, I would have two sections. Cut the number line on at 0. I'd have this section to the left of 0 and this section to the right. So we have got to check both sections. So I need a number on this side. Whether you see it or not, I'm going to put in, say, negative 8. So let me store negative 8 into my calculator. I'm going to type in left-hand side. And get an answer. And I'm going to type in right-hand side. Get an answer. So now I've got to go back to my inequality. Now the left-hand side was negative 32. Right-hand side is 16. So here's the statement. Negative 32 is less than or equal to 16. If that's a true statement, I shade that side. Well, it happens to be a true statement. So let me go get something to shade. So let me start right here and I'll go this way. I guess I move it up just a little bit, you'll be able to see. So starting here and going to my left, every number there will work. Well, let me get a number over here. Remember, check each region by getting a test value. Do not use the boundary point, that won't help. You have to actually get a number in the region. Let's use 5. Or 1 or 2 or 3. It's up to you. 10, 90. Let me type in right-hand side. And left-hand side. So here's my statement. 20 is less than or equal to negative 10. No, I don't think so. So I do not shade false statements. So this is the graphical answer to this problem, to this inequality. Now, interval notation. As I come in from the left, I hit an arrow, which means negative infinity. I go all the way up to 0. And since it is a solid dot, remember I have to use a bracket. So my solution would be parentheses negative infinity, comma 0, bracket. So there's that one. Let's try this one. Notice on this one I've got two inequalities, so that means I've got to have two statements. I'm going to have the left-hand side starting from x going this way, and then the right-hand side inequality, so starting at 1. So I'm always going to use the middle, but the middle will go to the left, and then I use middle to the right. So let's change this first inequality I see to an equal sign. Okay, now you can multiply by 3. I've got a whole number here. I could move my negative 1/3 x. So there's a lot of different ways you can do these. Just so you need to, go and do the problem how you feel most comfortable with. I think I'll add the 1/3 x to both sides. And then I'm going to multiply by 3. So I should have x equals 3. Let's see if I do. Yep. Alright. Now I've got that one, but I also have this other inequality. So I'm going to change it to equal. So I'm going to have the middle equals 1. Down just a little bit more. Probably I subtracted 1. If I have whole numbers, I'll go ahead and congregate them to one side. So I'm going to subtract 1, so I'll have a negative 1/3 equals 0. And multiply both sides by a negative 3, because that'll make us a positive 1x here, but on this side I think I'll still end up with 0. So these are my two solutions. Now both of these are less than, so that means I need an open dot. So let me go borrow this open dot, and I'm going to put it first at 0. And then let's put it at 3. I guess I could center it a little bit better. I guess that's about the best I can do. Now if you'll notice, if I could pull off this whole number line and cut on the boundary points, I'd have this section here to the left of 0. I'd have this section in the middle between 0 and 3, and I'd have this section that's to the right of 3. So let's go check them. Now if you'll notice, my x is in the middle, so really that's all I need to put in. Store my number that I want to use out of the section, type in the middle, and then see what kind of statement I have. Let's use negative 2, because that'll be in this section. And I always work from left to right. I always do that. Let me type in the middle, 1 minus my 1/3 x. Let's see what we get. 1 point bunches of 6. So let's say 1.7. So 1.7 goes in there, here in the middle. So 0 is less than 1.7. 1.7 is less than 1. Now in order for this statement to be true, this number here has to be between 0 and 1. And 1.666 is not. So this number over here gives me a false statement. So don't use that one. Let's try 2. So store that in. Let me do second enter to recall. Let's see what number we get. That's 1/3. So 0 less than 1/3 is 1/3 less than 1. Hopefully you said yes. So that means this section right here in the middle, I need to shade it. So let me go get me a shape here. So I'm going to start here. I wanted it to go a little bit further. It didn't go further. Hopefully you can see the blue. Let's see if I can make it a little bit bigger. That's better. I'll use that. So I've shaded that, but now I've checked this first section. It didn't work. Middle section worked so far, but now I've got to check this section here. I think I'll move that up just a little bit so you can actually see. All right. What, 8? I'll try 8. 8's over there. 8, storing for x. Second enter. Negative 1.666. So is 0 less than negative 1.7? And hopefully you say no, because it's not. So I do not shade that section. So the only section I have to shade is here in the middle. So here comes interval notation. Coming from the left, I hit the shading at right past 0. The shading ends right before 3. So if you remember, I have to use parentheses on open dots. So I'm going to have parentheses 0, comma, 3 in parentheses. And that's my solution using interval notation. One more. Sort of similar to this one here. It's a 3-part. I've got the left, middle, and right. So let's do the left hand first. I'm going to make that equals. Now, anytime you have one fraction equaling one fraction, I always cross multiply. So I'm going to go 3 times that quantity and 2 times 1. See what I did? Distribute the 3. So now I'm going to subtract 3. So I'm going to have 3x equals negative 1. And then divide by 3. So I'm going to have x equals negative 1/3. So this one, I need an open dot. So let me put it about, I'll go with about right there. Okay. Let's go to the other side. Make that an equals for just a second so I can find out my boundary. Cross multiply, so I'm going to have 3 times that quantity and 2 times 2, which would give me a 4. Distribute your 3. Subtract 3, so I'm going to have 3x equals 1. And then divide by 3, I'm going to have x equals 1/3. But now this one, because it's less than or equal to, I need a solid dot. Let me go borrow my solid dot. I'll put it right here. Does it look like about a third to you? Alright, so I've got that. So now I've got, like I had before, 3 sections. I need to check this section here. So let me get my calculator. I'll put in negative 1. Again, x is in the middle, so let's see what happens. Parentheses, x plus 1, divide by 2. So 0. Is 1/3 less than 0? No. So I do not shade that section. Let's try 0. So 0, storing for x, if you need to. Some people like to use their calculator. If you put 0 here, we should end up with 1/2 for the middle. Let's see. Okay. Now, if it's easier for you to look at these as decimals to make a decision, then you do that. 1/3 is 0.3. It repeats. So let's see. 0.3 is less than 0.5, which is less than or equal to. Now, 2/3 is 0.66666. So to make a decision, I'm just going to call it 0.7. So we've got 0.3 less than 0.5. So far, so good, which is less than or equal to 0.7. So that does give me a true statement, so I'm going to shade there in the middle. I wonder if I can shorten that. I can. Now let me move it down so I can show that I'm shading this part. Okay, so I shaded the middle. Now let's try 1. So 1 storing for x. So second enter. My answer is 1. So 1/3 is less than 1. That's true. But is 1 less than or equal to 0.7? That's not. Alright? So my only true statement is here in the middle. Now, you have to check all sections. You've got to make sure. So here's my interval notation. As I come in, I hit an open dot, which is a parentheses. This is -1/3 up to 1/3, and I need a bracket for that. So let's see if there's my parentheses, -1/3, comma 1/3 with a bracket. It would be to your advantage to put those fractions here, so when you read it, you won't have to go back over here. Okay? That's it for this section. Thank you.